attending, coming along to witness what I'm going to say is our first in-person webinar at NMIS. Previously these things have been done remotely, and I know this is probably still remote, but we actually have our members here in attendance with us today, which is a good sign of recovery and getting things back to normal, as I'm sure everybody wants to do. Just a little bit of information. This machine and demonstrator was filmed here on MX 520, so it was machined here and recorded, and then the presentation was put together. With me today is Ben from Sandvik, who's going to introduce himself.
Good morning, everyone. My name is Ben Lodge. I'm the Solid Round Tools Product Specialist at Coromant.
Thanks, Ben. And Michael McGill.
Morning, everybody. My name is Michael McGill, and I'm the NIKKEN Business Manager for Scotland.
We also have in the room Tracy McCarroll, the Membership Engagement Manager for NMIS, Chris Golightly from Sandvik, and Gary Essler from Sandvik, who joined us to help put this together. So, I'm going to start presenting the slides, so once again, thanks for coming along. So NMIS Insights online, the next generation of 5-axis machining. So just brief housekeeping. The webinar being recorded, will be made available on our YouTube channel. Microphones and webcams are turned off as usual to avoid any background noise. Please type questions throughout the session, and we'll answer questions at the end of the session. Use a hashtag for any questions on Twitter, and please, I know it can be difficult and takes up some time, but if you can complete the survey, that lets us know what you're looking for, and maybe what we can maybe do next in the way of webinar with members. It'd be really appreciated. And as I said, that's the first time we've had an in-person webinar, so any feedback on this would be appreciated as well. Let's just improve how we deliver content to you. So the speakers, although I'm not probably doing much, Crawford Cullen, Senior Manufacturing Engineer at NMIS, Ben Lodge from Sandvik, and Michael McGill from NIKKEN. So it is a National Manufacturing Institute, and I know some people have probably seen this on other webinars, but it gets the message out to people who are maybe attending for the first time. So we're an industry-led manufacturing research and development facility. The research industry and the public sector work together to transform skills, productivity and innovation, and to attract investment and make Scotland a global leader in advanced manufacturing. And I'm sure you agree these things are very beneficial for the future of Scottish engineering and production. So NMIS will increase productivity by reducing barriers to innovation, stimulate investment and increase manufacturing competitiveness, that's hard for me to say, catalyse job creation and strengthen supply chain links, and inspire and attract talent and equip current future workforces with the skills businesses need. I think that's also very important. Try to attract new business and put that skill force that's required and needed, and work with manufacturing businesses of all sizes in multiple sectors, providing benefits across the whole of Scotland. So the One Scotland team is operated by the University of Strathclyde and supported by the enterprises you see here, including the Scottish Government, Scottish Enterprise, Skills Development Scotland, Catapult. In the NMIS group, already in place and working with you guys is the Lightweight Manufacturing Centre and Advanced Form and Research Centre, where we sit just now. The Digital Factory, which is a new build, will open later this year, and that will provide collaborative workspace that people can come in, join us and work together, again strengthening business in Scotland. So for the content for today, I'll hand over to Ben to introduce what's happening with Sandvik.
Thank you. So today we're going to be seeing a machining demonstration. This is a replica of our prime insert. It's a scaled up version, that's for sure. We're going to be using different techniques and different tools from our product portfolio. So I'll hand over to Michael.
Thanks, Ben. From NIKKEN, the first video we see is a video about Tool ID, which is a subset of TP32 tool management system. And the primary function of Tool ID is to manage and control tool identification data, and it means to quick and easy data transfer to and from the machine control. The next video will be about the workholding we're using in this morning's demo, and the workholding is supplied by our technical partner Triag, who we formed a partnership with in 2015. Triag offers a broad range of modular clamp technologies, and today's demo uses our 5-axis vise with the longer jaws used for an extended grip. One of the main advantages of this vise is the jaws are self-starting and therefore don't need the addition of the standalone starting unit.
And as I stated earlier on, at the end we'll do questions. So, I want the first demonstration. Hopefully you enjoy this. It was a very interesting piece of work.
So for today's machining demonstration, we're going to be machining EN24T. So for the first tool, we're using one of our Highfeed face mills. This is the 745 cutter. We're running at 165 meters a minute and 0.5 with our feed. AP is 2 millimeters, and we're doing a 90% step over with this tool. As we can see here from the animation, we're keeping a constant run around the face milling process. So here we're rounding around the corners, so there's no sharp movements, no 90-degree movements that will cause vibration with the cutter. Next, we've got our Highfeed side milling. So this is utilising one of our solid round tools products. So this is the 2N342 in the 1730 grade. So here, utilising the Highfeed side milling method, we're ensuring that we use the full AP, the full length of the cutting edge, and a 10% step over. So this is running at 267 meters per minute and a 0.185 feed per tooth. Next, we make a step change within our cutting data. So we can see here we're running at the same AP, so the same length of cut, but we're making a larger engagement when it comes to our AE. So here we've got a 20% step over, so we're doubling our step over. We're running at 231 meters per minute and a feed per tooth of 0.01335. Next up, we have our 2P370. This is a 10 millimeter cutter, and this product has capabilities of 4 times D, so we are able to machine up to 40 millimeters of depth with this 10 millimeter cutter. But what we are doing is a 34 millimeter again, and a little bit of a smaller engagement. So this is an 8% step over, so that's 0.8 millimeters in total. For this tool, we're running at 213 meters per minute and a feed of 0.1109. So here we're running the same tool and we're putting the angles onto the insert this time. So we can see here we're utilising the 5-axis capabilities of the machine. For this we're running at 213 meters per minute and a feed per tooth of 0.1109. And again, 34 millimeters for our AP and a 8% engagement step over. Now we're coming back to one of our indexable products. So we can see here we've got our DS20 range of drills being used. So this is a 27 millimeter diameter hole that we're going to put in here. And we're running at 184 meters per minute and a feed of 0.09 per rev. And this is going to a full depth of 65 millimeters. Our next tool, we're coming back to the Plural HD range of products. So this is the 2F342, 12 millimeter. And this is where we're high feed side milling within the pocket. So we're putting the angles and the surfaces within the hole that we've just produced. So this is running at 203 meters per minute and 0.16 feed per tooth. AP is 7.5 and our AE is this 8%, so we're at 0.94 for this tool. Next up we have one of our indexable products. So this is our 415 high feed cutter. This cutter is a high feed, so it's a 15-degree entry angle on the bottom of the cutter. So we can run at really high feeds per tooth. So we can see there 145 meters per minute and our feed per tooth at 0.64 due to that entry angle. So it's also about keeping that hex, that chip thickness there when we're using these kind of products. AP is 0.7 millimeters and we've got a step over of 17.5%. Next up, we're going to scan the surface of the insert. So we're going to put in the geometry and the detail into the top surface. So for this, we're going to be using a ball nose cutter. For this, we're running at 226 meters per minute and a feed of 0.08. And the maximum that AP we've got on this is around 1 millimeter. We're not going any bigger than a 1 millimeter depth of cut. And one thing that we've got to keep in mind when we're doing this kind of surface, obviously there's two different approaches that we can see there. So we could rough this out with a square geometry, but we can see there it could give us a more uneven stock left over, which can cause problems and result in tool chipping. So wherever possible, it's better to have a radius cutter. So we can see there these smaller cuts, less stock to be removed, which will be much kinder on the tool that's going to follow it. What's also important is how we machine the surface as well, and we can see here from the pictures on the screen, you know, there's two methods. One is the pull method, one is the push. And you know, wherever possible, we want to be utilising this pull method. You know, we're engaging on the radius of the cutter, as we can see in the picture. You can see the start and the end of the cut. Whereas in the push method, we can see there it crosses the centre line of the cutter. So there's quite a large risk of chipping, because obviously the closer we get to the centre of that tool, the lower the VC is. So at the exact centre, the VC is lower. You know, it's a lower effective diameter, so it can cause a lot of problems and also lead to a worse surface quality. So wherever possible, we want to utilise this pull method. Next, with this tool, we're going to chamfer the edges, both on the external of the insert, but also in the centre hole as well. So again, 226 metres per minute, this time a feed of 0.05 and an AP of 0.1. And now we're going to look at some different ways where we can full slot, and we're going to utilise some of the tools that we've already seen within this demonstration. So first up, we've got our 415 cutter. So with this tool, Highfeed tool, as we spoke about before, 135 metres per minute, a feed of 0.386 feed per tooth. But obviously we've got a small engagement, so this is 0.415 on the AP, but it's 100% on the AE, so we're utilising the full 16mm capabilities of this product. And lastly, we've got our Plural HD product. So this is a product specifically designed around large engagements and certainly full slotting applications. So the 2N342, 16mm diameter that we've used before. And here we can see we're running at 103 meters per minute with a feed of 0.09 on our feed per tooth. And because of the design of this product, we're able to go the full depth. So here we're doing the 16mm depth for the 16mm wide slot.
Just move on to the next video now.
Tool ID system is a solution for transferring data between presetter and machine tool automatically and with minimal manual operator intervention. The system is built around assigning a unique serial number to each tool assembly, in this case via a data matrix QR code, as you can see here. These QR codes can be supplied sequentially on a reel or even laser etched directly onto the tool holder. The QR code only contains unique serial information or the unique ID of the tool and can be tied in with existing serial numbers if you have them available. Measuring the tool is conducted as normal, first clamping the tool in the spindle and bringing the area of interest into view. In this example, we're using the advanced E46L presetter, which makes measurement very quick and easy, although the tool ID system can be applied to a number of other models within the range. Once we're happy with the measurement, we make use of the TID button, shown here by a picture of a scanner and a QR code. This activates the scanner, we scan the tool, and the current tool data is retrieved from the database. These fields you see here are completely customizable and can be changed depending on machine tool and application. We simply click Z and X to pull through the measured values. Once confirmed, press DNC, rescan the tool as a safety measure. This data is then uploaded back to the database. Over at the machine, we can view the tool manager. In this example, we're going to load into pot 54, which you'll see has a default length of 9999 and no other data. We load our tool into the carousel, and as we can see, it's automatically scanned by the reader placed there. The IPC handles communication between presetter, database and machine, so we select Load Tool and the data is automatically uploaded to the machine. This data from the presetter is now clearly visible in the tool manager. The measured values have flowed through. We can see the tool number and offsets exactly as they were measured on the presetter. The data flow can actually take place in two directions. So if we make a change on the machine, in this case we're going to mark the status field as 1 or used, this can flow back to the presetter and database. This is a very useful feature if tracking things like tool wear, usage, or maybe even interfacing with our full tool management solution, TP32. Unloading the tool is simply the reverse of loading. You select Unload Tool and the data is removed from the NC control. You can now physically remove the tool from the machine carousel. Presetter. If we want, we can re-inspect the tool, or for example, we can simply rescan the QR code. The data is retrieved once again from the database, and we can see that that tool status field is now updated as we did on the machine tool. This system is not only limited to one preset to one machine, but can be expanded to suit any environment and application, including things such as fixture tracking or gauge tracking. Please get in touch with us or follow us at the links that you can see now for more information.
Thank you, everyone. Hopefully you enjoyed those videos and they're informative. I think we now have some questions. Michael?
Yeah, I've got one here. It says, are there any advantages, disadvantages from using the QRID codes compared to the RFID method? And probably one of the main advantages is down to, if you've got a machine shop that's got existing tools, to use the RFID method, Crawford, you generally have to modify your tools. Put them up into a setup, machine out, pocket out, glue one of the chips in. The QRID is just a transfer. They can, as the video said, they can be done sequentially and they're actually really cheap just to order. Or if you've got a laser etch, you can just laser etch your tool. There's another one there, can the ID scanner be built into the presetter to make this an automatic part of the process? I would need to take advice on that one. There is a bit of safety nets built in to ensure that you can do a proper process to ensure that you're recording and updating the appropriate data. So I'll need to see how automated that can be done. So I will take a note of that one and get back to somebody on that.
Okay. Is there any more, Debbie? Yeah.
No, that's the only two that I'm seeing in the chat box just now, unless anyone else would like to add any.
I think we're okay. If anybody wants to raise their hand, I'm sure we can unmute them. If anybody wants a quick question. I think that's us. Okay. I'd just like to say thanks to everyone for attending. I know your time's precious and we appreciate it. And as I said, any feedback would be great, either for NMIS or the guys of put this presentation together. I hand back to you, Demi. Thank you.
Okay, thanks very much, Crawford. Yes, and as Crawford has just said, thanks very much for taking the time